Hi, my name is Caden Seward, and I'm going to be showing you a tutorial on how to secure a Python server um, for HTTPS connections. We're going to start with a walkthrough of the code that we're going to need, and that's going to involve the actual server itself as well as key generation. Then we're going to move to a demo. And then finally, we're going to look at the Wireshark packet to make sure that it's actually secure. So yeah, getting right into it, we've got these imports right here. We're going to need all of these. And then going down, we've got standard web server stuff, just creating a parser to check ports. And then we've got some context. And this is our new code. We're going to create some SSL context, which is just some options. And then we're going to load a cert chain, which is going to include a public key and a private key. We're going to talk about how to generate those later, but for now that's just the relative file path of them. Moving on, we're just going to continue just the same. We've got one new line of code here. We're going to wrap the socket that we bound to a port and started listening to. We're going to wrap that with SSL. And so we're going to turn that into a secure socket. After this, it's just going to turn on just like normal and start accepting requests. So yeah, that's how the server works. Now we're going to talk about key generation. So first you're going to need a private key. This is going to take a file name and a passphrase. The passphrase is just what you're going to need to use to turn on the server. This right here is going to tell it the Python what technique to use, and so we're going to use RSA because that's a really secure method with a key size of 2048. That's standard, and the default method of doing so. This exponent can be any high number you want. Just make sure it's a large number. This is going to define that the passphrase is going to be an UTF-8 standard. And then this is going to tell Python what algorithm to use. So now it's going to do all of that and write that to a file so that we have a full private key that we can do whatever we want with. Then it's going to return that and we'll have a private key to use. So every private key needs a public key, and so that's what this is doing. You're going to take that private key and a new file name, and then a bunch of arguments such as location, country, locality, organization, and hostname, and you're going to turn those into a working public key. So it's going to take all of that, a valid time that it's valid for. They can only be valid for a certain time for security reasons. This one's going to be 30 days, so 1 month. And it's going to take all of that and build our public key. So we're going to build it. We're going to sign it with our private key. That's important. We can't have a public key without a private key because otherwise there's nothing that you can, if you encrypt it with this public key, you won't be able to decrypt it with anything. So it's going to take all of that information, write it down, and then we're going to have that public key. After this, we're going to have a CSR. This is going to take our private key and a new file name, and then arguments similar to before. And it's going to generate an authority so that we can authenticate our keys. That way they can actually be used and accepted by our client. So it's going to take a lot of those arguments. This one's very similar to the public key generation. I'm going to take these guys, build it into a CSR certificate, open a file, and then return that certificate. Finally, we just have to sign that certificate. We're signing ourselves, so that makes it super easy. We're going to take that public and private key and their file name. We're going to sign it until a date 30 days from now, build this, and then basically just write it to the file. Super easy. So now that we've seen how this works, we're going to see it in action. So we're going to close this guy and then start up our server. So I have this set up right here. I'm just going to start it just like normal. We're going to enter that PEM phrase. Mine is hello, all lowercase. And so see, now our server is ready to accept those requests. All right, so here we're just going to make a request to this server using our secure web client and our port 2080. And as we can see, once we press enter, we have a warning here. So that's how it's going to work. But then we do get that secret message. And that's not hard-coded, as you can see here. Our server did do something. It received this request from 2080, from Python requests, and it's going to keep this, yeah. And we responded with the correct response. And so yeah, it all worked just how we expected. But what we didn't check is if it's actually encrypted, right? So what we're going to do is we're going to take Wireshark here, and we're going to make sure that it's actually encrypted. So we're going to start this loop back. It's going to capture only data from the local host. And so yeah, we're going to start that, and then we're going to send that same command again and show that it's encrypted. So we're going to start that. We're going to run this command again, and there we go. We're going to see that we have data coming in, and so all we have to do is make sure that it's encrypted. So let's look at server hello, and I think scroll down to transport layer security, and then we're going to look at this application data, and if we look, we see that the application data is encrypted and it can't be read. So we've done it. Through all of that, we've created data that can't be seen by packet sniffers. So it's much safer, much more secure. Awesome. All right. I think that's all I have for you. So bye.